Big data. There is a lot of hype going around this term for quite some time. Want to know why? Stick till the end of the video to find out. Hello everyone, welcome back to another video. So in today's video, we will discuss about big data, the different V's in big data and about Hadoop. Stay tuned. You are watching the Artificial Intelligence in Data Science channel. Subscribe for more amazing videos. So what is big data? Let's have a look at some of the definitions of big data. Gartner defines big data as follows. Big data is high volume, high velocity, high variety information assets that demand cost-effective, innovative form of information processing that enable enhanced insight, decision making and process automation. As per IBM, big data is a term applied to datasets whose size or type is beyond the ability of traditional relational databases to capture, manage and process the data with a low latency. Big data has one or more of the following characteristics: high volume, high velocity and high variety. So in simple terms, we can say that big data refers to the data that is very massive, complex, comes at a very increasing rate and that which cannot be processed using traditional methods. So what do companies do with this data? Big data can be analyzed by data analysts, researchers and companies to find existing correlation in the data and to make strategic business decisions from them. To know more about how data is used to derive insights, check out one of my previous videos. I'll add a link in the description below. To gain some more understanding in big data, let us look at the different V's in big data. You might have already noticed the 3 V's in our definition of big data. Yes, you guessed it. It's volume, velocity and variety. The other 2 V's which I would like to add to this list are veracity and value. So let's look at them in detail. Volume. Volume refers to the amount of data generated. The size of the available data has been growing at an ever-increasing pace. Data is generated by individuals, companies and machines. Vast majority of people are using more than one device: mobile, laptop, tablet and wearables to name a few. It has been estimated that we generate more than 2.5 quintillion bytes of data per day. To put that into perspective, that is around 10 million Blu-ray DVDs. Wonder how all this data comes in? There are more than 294 billion emails sent per day. More than 500 million tweets are tweeted per day. Facebook generates 4 petabytes of data per day. 65 billion messages are sent on Facebook and 5 billion searches are made on Google per day. By 2025, it is estimated that 463 exabytes of data will be created each day globally. Velocity. Velocity refers to the speed at which data gets generated, distributed and collected. Processing of data at the rate at which it gets generated is a major task of big data analytics. For example, modern cars have hundreds of sensors which keep collecting information for data processing. This kind of data needs to be processed at a tremendous pace for smooth operation. Airplanes also have a huge amount of sensors which collect and store data for processing. These kind of data are used to process information in real time. To put things into perspective, 90% of the total worldwide data available was generated in the last couple of years. Variety. Variety refers to the diverse amount of data that gets generated. The generated data can be in form of structured, unstructured or semi-structured data type. Organizing and storing this data in a meaningful way can be very difficult. Some of these types of data include audio, video, photo, GPS data, medical data, data from wearables, instrument measurements, web document, and internet behavior. Ever wondered how we get real-time traffic updates on Google Maps? Google uses smartphones as sensors to determine the traffic conditions. They use the data collected from smartphones to analyze the traffic conditions on a route and suggest the best route for navigation. Veracity. Veracity refers to the certainty of the data, that is, how accurate the data source is. With the increase in mobile users, it becomes difficult to track the reliability and accuracy of the data, as it may go through a number of different sources. Different processes are required for keeping the bad data out of your system. This includes removing bias, checking for abnormality, removing false or duplicate data. This is to ensure that the data used for storing and processing is a reliable data. Did you know 1 in 3 business leaders don't trust the data they use to make decisions? Having unreliable or bad data in a system can have a negative impact on the industry. Value. The main reason why people spend a lot of time understanding big data is to derive value from it. The information extracted from big data analytics can be used in different fields such as business, research, healthcare, service sector, etc. For example, big data can be used to identify browsing patterns on websites to figure out which product the customer is more likely to buy next. This helps you target audience better by recommending personalized ads. Ever notice getting the different ads of product that you wish to buy? Well, now you have an idea of how that comes. Cloud computing played a great role in development of big data. According to McKinsey, the emergence of cloud computing technologies have highly contributed to the launch of big data era. Cloud computing allows users to access highly scalable computing and storage resources through the internet. By using cloud computing, companies can use server capacity as needed and expand it rapidly to the large scale required to process the big data sets and run complicated mathematical models. The cloud is a set of highly powered servers at a particular location. They can often view and query large datasets more quickly than a standard computer. Some of the applications used in big data are Hadoop, Apache Pig, Apache Hive, Apache HBase, Apache Phoenix, Apache Spark, Apache Zookeeper, Cloudera Impala, Apache Flume, Apache Scoop, Apache Uzi, and Apache Storm. Hadoop. The Apache Hadoop is an open source software library framework that allows for distributed processing of large datasets across different clusters of computer. Hadoop framework is written in Java and developed by Doug Cutting, who named it after his son's toy elephant. Instead of using a single computer for storing and processing the data, Hadoop uses multiple computers to analyze massive datasets in parallel and more quickly in a Hadoop cluster. We will now look at the different modules in Hadoop. HDFS. Hadoop Distributed File Structure allows data to be stored easily across large number of devices in an accessible format. This is the main backbone of Hadoop. It supports large datasets and also provides a high fault tolerance. Yarn. Yet another resource navigator manages and schedules all the resources and decides what happens in each node. MapReduce. MapReduce is a programming tool used by Google for indexing its search operations. This framework helps in parallel computing of data. This is the heart of Hadoop. The map layer takes the input, converts it into key value pairs or tuples. The reduce function takes the output of the map layer as the input and processes it and produces similar smaller key value pairs as output. Hadoop Common. It provides all the libraries and utilities used by other Hadoop modules. Hadoop Ozone. Ozone is a scalable, redundant, and distributed object store for Hadoop. Ozone is built on highly available replicated block storage layer called Hadoop Distributed Data Store, or the HDDS. Hadoop cluster is a hardware cluster that consists of a group of computers called nodes that are networked together for performing parallel operation on the data. Compared to conventional computing, Hadoop clusters can store and analyze a large amount of structured and unstructured data. Hadoop clusters are known for the speed of data analysis process as highly scalable. If a cluster's processing power is affected by the growing amount of data on the cluster, additional clusters can be added to increase its performance. Hadoop clusters are said to be very resilient to failure as each piece of data is copied to another cluster node. So in case if one node fails to operate, the data can be taken from the other cluster nodes. That brings us to the end of the video. Hope you got an idea about big data, the V's in big data, and about Hadoop. So what are your thoughts about the hype of big data? Comment below. See you in the next video.